There is few more things with filters. Notice, okay, there is a pole at the origin. Things are, these are magnitude response, not in decibels case, okay, not in dB scales, and these are also, supposedly exact, not Bode approximations. Okay, there is a pole at the origin, it drops roughly. There is a zero at the origin, it goes like this. Okay, there is a pole somewhere, remains a constant. The way to make sense out of this. Then there is a zero at z1, starts at k. No, this value, starting value is k, starts at k, and then at that cutoff frequency it starts going like this. The Bode approximation. Decibel it's going to do like this. Okay, phase is a different story, but at least know how the magnitudes behave. Pole at or zero at origin, simple pole, simple zero. We kind of know whether it's all pass, low pass, what kind of a behavior it gives. We kind of know. Now, interestingly, k into s plus, let's have a zero and let's have a pole. But whether the pole comes first or zero comes first, okay, now we'll determine a lot of things. Or is the pole equal to zero? Okay, has, they are equal and opposite, then it's a all pass filter with the thing, 0 to 180 degree. With the example we did, APF we did, it's of this form. Zero comes first, zero is closer to the origin. Okay, it starts going this way, then pole comes, so it changes direction. Instead of going that way, it changes direction. Notice this has a peculiar feature that it allows some low frequency components, but it better allows high frequency components. It doesn't exactly get them to zero, but it does kind of attenuate low frequency. Okay, here nothing goes. Nothing passes. Here something passes. Okay, and then finally you could also do, you can have the pole first, so it starts dropping, then you can have a zero. Instead of going this way, you get it this way. Again, something passes at high frequencies. So now we have our control over, okay, where do we place the zero, where do we place the pole, that will know, we know the different frequency responses. So given a quickly RC, we can quickly decide on its value.